Hello guys, how are you doing? Welcome to another video, and before I move forward, may you please hit the subscribe button so that you can keep getting this content. In this video, I'll be looking at finding the area of a triangle and parallelogram. I have a triangle with me right here, and generally we know that the area of a triangle is found by saying half base times height. But in this case, whereby we have such a triangle that contains angles that we have to consider, we can see that this is the angle that we have, and because this is a right angled triangle, the edge that I have here is going to be the opposite, and this A is going to be the hypotenuse, and what we have right here is going to be the adjacent. That leaves us with triangle BCD. Our sine C is equal to h over A. So to get h, we say A multiplied by sine C. Therefore, the area of this triangle is going to be half times the B times A sine C, which is half AB sine C. This formula right here is very useful when two sides and the included angle are known. We can use this formula to find the area of the triangle. I'm going to do an example. We have a triangle ABC, and the formula for finding the area is half AB sine C. And in this case, to find the area, we're going to say half multiplied by A, which I'm going to take as 5, our B, which I'm going to take as 7, then our sine C is going to be sine 52. And we are going to get 13.8 square centimeters, and this is to 1 decimal place. This is the area of our triangle. Moving on, I'm going to look at the parallelogram. This is an example of a parallelogram. A parallelogram has got two sides that would be parallel. So if this side and this side, they are parallel, and this side and this side, they are parallel. It has got two pairs of sides that are parallel. The formula for finding the area is the base times the height. But from what we have here, the height is an unknown value. So we have to find the height first. And using our trig, I'm going to sketch this triangle. From this whole diagram, we extracted this part, which I have drawn right here. By looking at this, this is the opposite, this is the hypotenuse, and this is the adjacent. And we have the opposite and the adjacent. So we are going to use sine theta, which is equal to opposite over adjacent, to find our edge. That is sine theta is equal to O over A, and to find our O, we then say O is equal to A multiplied by sine theta. Hence, the formula for finding the area of a parallelogram becomes B multiplied by A sine theta. I'm going to go ahead and do a few examples. And in all these examples, we're going to be finding the areas of the given shape. Number 1, we have a triangle ABC with two sides and an angle. So from the formulas that we got, our A is equal to half AB sine theta. Substituting the known values, we have half multiplied by 11 multiplied by 9 sine 35. And our answer correct to 1 decimal place will be 28.4 square centimeters. Example number 2, we are given these parameters. B, that's a side of a triangle. C is also another side of the triangle. And then when you see this means that it is the angle. So the angle B is equal to 10 degrees and the angle C is equal to 65 degrees. I'm going to quickly sketch this triangle. This is the triangle that I just sketched with the given parameters. For us to find the area of this triangle, there is something that I hadn't mentioned before. You have to use the angle that subtends the two sides. So we're going to use this side because we're given the length of this side AB and the length of the side AC. That means we have to have the angle A for us to find the area. And to get the angle A, we know that internal angles of a triangle add up to 180. So we're given 2, hence we're going to say 180 minus 10 plus 65 is equal to angle A. Angle A is equal to 105 degrees. That means this angle right here is 105 degrees. Then we go ahead and plug in the formula. Our area is half AB sine theta. Half our A, we can take 1.8 multiplied by 3.2 multiplied by sine 105, and we get 2.78 square centimeters. That's how you get the area of the triangle. Example number 3, we have a parallelogram with the given two sides, 10 centimeters and 7 centimeters. We find the area of a parallelogram by saying AB sine theta. Hence, we're going to get 10 times 7 times sine 70 degrees, which is equal to 65.8 square centimeters. Number 4, we are given a parallelogram and we're asked to find the area shaded, and we're told that AE is equal to a third of AB. We know that AB is the same as 12 centimeters because these two are parallel. To get AE, we're going to say a third multiplied by AB, which is 12, and we get 4 centimeters. That means AE is 4 centimeters. We are going to start by finding the area of the parallelogram. I'll just call it A para, is equal to AB sine theta. And our A, we can take 6, our B is 12 times sine, and the angle that we're given is 72 degrees. And from this, we get 68.476 square centimeters. And then we find the area of this triangle right here, which is not shaded. And to find the area of the triangle, we say area is equal to half AB sine theta, and our half times A, which is 6, times our B, we're going to take 4 because that's the length of AE that we got, times sine 72, and we get 11.413 square centimeters. So to find the shaded area now, we subtract the two, the area of the parallelogram and the area of the triangle. So that is 68.476 minus 11.413, and we get 57.063. Rounding it off to one decimal place, that's 57.1 square centimeters. This is the area of the shaded region. Moving on to example number 5, we are given a rectangle that is divided into two triangles. To find the shaded area of this diagram, I'm going to start by finding the area of the rectangle, which is found by saying length times width. And from this, the total length, because I have from this point to this point is 12 meters, and then from this point to this point it's 2 meters. So the total length is 14 meters. My length is going to be 14 times my width, which is 7, and I get 98 square meters. Then if you look at the shape that is unshaded, this one, we can clearly tell that this is a parallelogram. So I'm going to find the area of the parallelogram, and we find this by saying base times height. And my base is 12, which is from this point to this point. That is 12 times 7, and we get 84 square meters. Now, to find the shaded area, I'm going to subtract these two, and we get 98 minus 14, which is equal to 14 square meters. So that is it, guys. That is how you find the shaded area of this diagram, and use the formulas that I gave you in the very beginning, the formula for finding the area and the formula for finding the parallelogram, and you get the answer that you need. See you in the next video.